Assalamualaikum and welcome to Cambridge Chemistry channel with sarwatahmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss the mole questions. So question number 1, 1.15 gram of metallic element needs 300 centimeter cube of oxygen for complete reaction at 298 Kelvin and 1 atmospheric pressure to form oxide which contain O2 minus ions. What could be the identity of the metallic element? This is the trial and error, and we will check all these elements. So uh, two elements from group 2 and two elements from group 1. So let's start. Let's say I have checked group 2. Magnesium when react with oxygen to form magnesium oxide. So balance the chemical equation. So this is magnesium and 300 centimeter cube. 300 centimeter cube of volume. So first calculate the mole of oxygen atom is equal to 300 divided by 24,000. This is cm cube. So the answer is 0.0125. By using mole ratio, magnesium ratio oxygen 2:1, 0.0125 ratio x. So the mole of magnesium is 0.0125 multiplied by 2, 0.0125 into 2. This is 0.025. Now in question 1.5 gram metallic elements are given. So then calculate mole is equal to, we have mole and mass is given 1.15. So mole is equal to 0. Mass over AR. So AR is equal to mass over mole. Mass is 1.15 and 0.025. In this way we can check AR of all elements. 0.025 1.15 divided by 0.025. So this is equal to 46. It means, now let's check the group 1. Group 1, sodium, Na plus oxygen to form sodium oxide. So balance the reaction to 4. And we know the moles of oxygen. Mole of oxygen is 0.0125 is the mole of oxygen. This is 4:1 and ratio x, and we have 0.0125 into 4 is equal to 0. Mole of sodium is 0.0125. So we don't know that which element is there, sodium or potassium, any element can be, but we can use over x over here, x of group and x2O. So now calculate the AR for group 1, mass over mole. Mass is 1.15 divided by mole is 0. This mole is 0.05. AR 1.15 divided by 0.05. This is equal to 23. It means 23 is the AR of sodium. So this is sodium element. So D option is correct. So this question you can solve like this. Calculate the mole of oxygen, then identify the AR of element by using mass over mole. So 4 options, out of 4 options, 2 from group 2 and 2 from group 1. You can check first group 2 and then group 1, or any element you can check. So in this way we can identify the element contain oxygen 2 minus ions. So next question is, which volume of, hope you will understand this question, which volume of oxygen at room temperature and pressure is needed for complete combustion of 1 mole of methyl propane 1-ol. This is methyl propane 1-ol mean 1 methyl 1 carbon and propane 1-ol. It means it is a butanol. The formula of butanol is, so let's erase this. So first write down combustion of butanol. This is needed to complete combustion of 1 mole of methyl propane 1-ol. This is the methyl propane 1-ol. CH3 CH3 CH2 OH plus oxygen, or in other words we can write down C4H10O. This is the molecular formula of this compound to form carbon dioxide and water. So first balance the reaction, place 4 over here, 5 over here. So 4 to the 8 and 5 13. The mole of oxygen is 6 to the 12 and 1 13. So this is 1 mole of C butanol या methyl propane 1-ol producing needs 1 mole require 6 moles of oxygen. So this is 6 mole and this is 1 mole. So 1 mole required 6 mole of oxygen gas. So over here the volume is given in decimeter cube. So let's calculate the volume of oxygen. If 6 mole is there, the mole is equal to volume of gas divided by molar gas volume, which is equal to 24 decimeter cube. So mole is 6, so the volume of gas is mole into 24 decimeter cube, because volume is in dm cube. The mole is 6 into 24. This is equal to 144 decimeter. So the volume is 144 decimeter cube. So the answer is B. So next question is, you have done this question in class. Now look at the next question. 2.40 gram of propane-2-ol were mixed with excess acidified potassium dichromate. The reaction mixture was then boiled under reflux for 20 minutes. The organic product was then collected by distillation. So when this is propane-2-ol is oxidized, if propane-2-ol is oxidized and it is the organic product was then collected by distillation. Distillation, then propane-2-ol, the formula is propane-2-ol is like this: propane-2-ol OH, this is CHOH and CH3. So this is propane-2-ol, that number 2, when it is oxidized in the presence of potassium dichromate and it is collected by distillation. So this is ketone CH3. See, this compound is formed CH3. So 2.40 gram of propane-2-ol were mixed with excess of acidified potassium dichromate. The organic product was then collected by distillation. The yield was 75%. What mass of product was collected? 1.74 gram. The answer is, so this is the yield is 75%, and we have to calculate the experimental yield which is produced during this reaction. So this is, we can solve mass relationship. Mass relationship. We know that CH3 12, the MR of this is 1 mole of propane-2-ol producing 1 mole of ketone. So 1 mole of propane 1-ol. The molar mass is 1 mole into 12 into 3 plus 3, 3, 6 and 7, 8 plus hydrogen is 1 into 8, and oxygen is 1 plus 16. So 36 plus 8 plus 16. This is 60 gram of propane-2-ol producing ketone. 12 into 3, 12 into 3 plus 6 oxygen, 3 and 3 6, and plus 6 hydrogen, and oxygen is 16. 36 plus 6 plus 16, this is equal to 58. So 60 gram producing 58 gram. So what would be the mass if 2.40 gram of propane-2-ol react with oxygen to form this compound. 58 into 2.4 divided by 60 is equal to 2.32 gram. So this is the mass of 2.32 gram. This is theoretical yield. Now we have 75% yield if the yield of product was 75%. So we know the percentage yield is equal to experimental divided by theoretical into 100. Experimental is unknown divided by theoretical 2.32 into x is equal to 75%. So 100x is equal to 75 2.32 and x is equal to 75 into 2.32 divided by 100. So x is 75 into 2.32 divided by 100. So this is 1 point. So experimental mass is 1.74 gram. So the A option is correct. So next question, which calcium compound contain 54.1% by mass of calcium? So this is the question. All compounds are calcium. So 54 point, which compounds contain 54.1% by mass of calcium? So calculate like this. Percent of element, we know first we can check this. Calcium is AR of calcium divided by MR of compound into 100. So we know that calcium is AR of calcium is, first check this compound 40, AR of calcium is 40 and MR of calcium hydroxide is calcium hydroxide MR. Calcium is 42 into 16 plus 1. So this is 16 into 2, 32 and 2. So this is equal to 74 74 into 100. 40 divided by 74 into 100. So this is equal to 54.1%. Now our answer question is required 54.1%. So this A option is correct. You can, if this is not correct for this compound, you can check other compounds like this. You can check calcium nitrate like this. You can check calcium oxide and calcium sulfate as well. So next question is use of the data booklet is relative to this relevant to this question. Which sodium compound contains 74.2% by mass of sodium? So you can check this question like this. So for example, 74.2% sodium carbonate. So we follow this method as I have done earlier. So next question is use of the data booklet is relevant to this. The answer is this sodium. Let's check this question also. Sodium oxide is Na2O and this is 46 plus 16 is equal to 62, and we know that 46 is the divided by 62 into 100. The answer is 74.2%. So that's why this is 74.2%. Next question is which volume of oxygen at room temperature and pressure is needed to complete combustion of 0.1 mole of ethanol? 0.1 mole of ethanol. Let's check this question. Which volume of oxygen at room temperature pressure is needed to complete combustion of okay, first write down the chemical equation. Question number 7. Chemical equation for this reaction: ethanol C2H5OH plus oxygen to form carbon dioxide and water, carbon 2, hydrogen 6, 3, 2 to the 4, 3, 7, and place 3 to the 6 and 1, 3 moles of oxygen. So first we know that 1 mole required 3 mole and 0.1 mole ratio X. So this is answer is 0.1 mole of ethanol. Similarly, this is mole and 0.3 mole of oxygen. And similarly 1:2 and this is 0.2 mole, 0. This is 2 mole and this is 0.2 mole. So calculate the volume of oxygen. 0.1 multiplied by 24, 0.3 multiplied by 24, 0.2. It is cancelled out because at room temperature it exists in the liquid form into 24. 0.1 into 24 is equal to 2.4, and 0.3 into 24 is equal to 7.2, and dm cube, and 0.2 into 24 is equal to 4.8 decimeter cube. So the question asks you to calculate which volume of oxygen at room temperature and pressure is needed for the complete combustion of 0.1 mole of ethanol. So this is 7.2 decimeter cube. The A option is correct. So next question is 2.3030 gram of ethanol were mixed with an excess of aqueous potassium dichromate. The reaction mixture was then boiled under flux for 1 hour. The desired organic product was then collected by distillation. The yield of product was 60%. What mass of product was collected? This is the same question which I have solved earlier. I just write down the chemical equation and you can solve by yourself and try this question. I just write down the chemical equation. This is ethanol C2H5OH plus oxygen, excess of oxygen. So it is converted into, in the presence of potassium dichromate, because this is 2 carbon alcohol. So in this it is aldehyde is formed. Ethanol is formed, C2CH3 C double bond OH. This is ethanol. And when OH is present at one, like this, if OH is present at carbon 1, so always this compound is formed. And if it is OH is present like this question, this is propan-2-ol. So because there are CH3 is present, this is propan-2-ol. No, this is propan-2-ol is written like this. Propan-2-ol CH3 CHOH and CH3. If OH is placed, number 2 carbon are in between the carbon chain, then acetone is formed like this. CH3 C double bond O CH3. This is very important point. And if OH is attached at carbon 1 like this compound is formed. So you can solve the question I have solved this. So this is the same. Please try this question. So this is the product, ethanol and ethanol. So by using mass relationship, so calculate the MR of this compound, this will be equal to molar mass, and then 2.30 ratio X. So this will be the theoretical yield, and then afterwards you can check this. Please try this question. Next question is 2.30. So this is a similar question which I have solved earlier. Immediate distillation, this is ethanol, and ethanol is ethanol. So the same question, the same chemical equation. So this is ethanol and this is ethanol. And this is ethanol as formed. So next question is ammonium sulfate in nitrogenous fertilizer in the soil can be slowly oxidized by air producing sulfuric acid, nitric acid and water. How many moles of oxygen are required? So let's write down the chemical equation. Ammonium sulfate NH4 twice SO4 plus oxygen to form H2SO4 producing sulfuric acid, nitric acid and water. H2SO4, HNO3 and water. 2 4s are 8. 2 hydrogen or 2 4 and 2 over here. 2 2s are 4 and 2 6 2 8. Now let's check the oxygen. 4 2 3s are 6, 4 and 6 10 or 2 12. This is 4 oxygen and 4 2s are 8. So just balance the reaction and identify the number of moles which is required for this reaction. So option is D. This is 4 is correct option. So next question is nickel makes up 20% of the total mass of a coin. The coin has a mass of 10 gram. How many nickel atoms are in the coin? 2.05 into 10 raised power 22. Okay. Now let's check the so question number 12. So the 4 moles of oxygen is required. So after balancing this reaction we get the moles of oxygen which is used to react with ammonium sulfate. And this is question number 13. We can check by writing the chemical equation of combustion reaction with aluminum, magnesium, phosphorus, and check the moles. 4 ratio 3, 4 moles producing 3 moles. So what would be the mole? 1 mole react with the oxygen. So in this way you can calculate. So 0.75 moles of aluminum, 0.5 moles of magnesium, and the least mole is of sodium. So sodium is correct option. In basic oxygen steel making furnace P4O10, impurity is removed by reacting it with calcium oxide. The only product of this is calcium phosphate. So let's calculate this reaction question. First write down the chemical equation. P4O10 P4O10 plus calcium oxide to form Ca3PO4 twice. So 2p. 2 4s are 8. Oxygen is so 3ca. Calcium is 3 and phosphorus over here 2, over here 4. So balance this reaction. Calcium 2Ca3 6 calcium oxide, and in this way 2 3s are 6. 6 is balanced. Phosphorus is balanced. Now look at oxygen. 4 2s are 8. 8 2s are 16. 10 oxygen and 6 reaction is balanced. Now look at the only product of this. In this reaction, how many moles of calcium oxide react with 1 mole of P4O10? So 1 mole of phosphorus 5 oxide react with 6 moles of oxygen. So just balance the reaction and find out the mole of calcium oxide. Now next question is, when sports model with a total air surface area 150 centimeter cube was evenly coated with silver using electrolysis, its mass increased by 0.216 gram. How many moles of how many atoms of silver were deposited per centimeter cube on the surface of the? First calculate the moles. Mole is equal to 0.216 and silver divided by 108 AR of silver. So this is equal to 0. Let's calculate 0.216 divided by 108 is equal to 2 into 10 raised by 2 minus 3. So number of atoms, calculate the number of atoms. Number of silver atoms is equal to mole into 6.02 Avogadro number 10 raised by 23. Mole is 2 into 10 raised by 2 minus 3 to 6.02 into 10 raised by 23. The moles are 1.2 into 10 raised by 21. Now check, this is how many atoms of silver were deposited per centimeter cube on the surface of the medal. So this is for 150 centimeter cube. So number of atoms ratio area. So 1.2 into 10 raised per 21 ratio 150 centimeter cube covered. So for 1 centimeter cube ratio x, cross multiply, and this will be equal to, I think so, 8 point. So let's check. 1.2 into 10 raised by 2 21 divided by 150. 8 into 8.0 into 10 raised by 18. So this is the answer. Into 10 raised by 18 is the answer. So N2O4 is poisonous, it can be disposed. What is the minimum volume? 0.5. This is a chemical equation. So 0.5 mole of sodium N2O4 needed to dispose of 0.02 moles of. So what is the minimum volume required? So this is concentration, so volume easily it can be calculated. This is mole. So first check the mole ratio and then find out the volume. Concentration, mole over concentration. So first check the mole, 0.02. N2O4 is poison, it can be disposed by sodium hydroxide. So 1:2, and this is 0.02 ratio x. So cross multiply, this is equal to 0.04 mole and 5 mole per dm cube. Now check the volume. You can calculate the volume by using this formula. Concentration is equal to volume is equal to mole over concentration, 0.04 divided by 0.5 mole per dm cube. So this is in centimeter cube. Mole dm cube into 1000 is equal to volume, 0.04 divided by 0.5 into 100,000 is equal to 80 centimeter cube. This is the answer. Hope you will understand these concepts. So let me know if you didn't understand any question.